Hi friends, welcome back. Today we're talking about simplifying radicals. Grab your notebook, you're going to want to write this down. If you haven't already, these are the best notes I can give you for this unit. For simplifying radicals, the first thing you want to do is memorize your friendly numbers, right? And what I mean by that are perfect squares, which we have here, perfect cubes we have here, and then we have our 2's, 2 squared, 2 to the third, 2 to the fourth, so on and so forth. The next thing we have are our rules of exponents. So if you need to, pause the video, write those down, and then come on back. Okay, so let's talk about these guys. For our first example here, now, this is what I mean by friendly numbers. I look at 8 and I think, oh, that's a friendly number. It's 2 to the third power. If you haven't yet figured that out or haven't yet learned that, that's okay. What you can do instead is over here, we're gonna say 8, and we're gonna say, break that down into 2 times 4, and then 4 can be broken down into 2 times 2, and you'll see we have 2 to the third power. So 2 to the third power to the 1/3 power. If you remember our rules of exponents, when it looks like this, we use our power rule. And so we multiply those together. A little bit of side work. 3 over 1 times 1 over 3 gives us 3 over 3, which equals 1. So 3 times 1/3 gives us 2 to the 1 power, which equals just 2. Excellent. So as we go through this, I'll be operating under the assumption that you know your nice friendly numbers, but if you ever need to break down a number, you can do it just like we did here. It's called prime factorization. Okay, for 16, I know that this is 4 squared, but I also know that this is 2 to the 4th power. So if I have 2 to the 4th power to the 3/2 power, and if you did 4 to the 2nd power, that's fine as well, it'll work. That's the fun thing about exponents is there's multiple ways of doing these. So looking at this, again, you need to remember that we multiply these guys right here. So we have 4 times 3/2. So 4 times 3 over 2. So 4 over 1 times 3 over 2. Cross cancel, divide that by 2, we get 1. Divide this by 2, we get 2. On the bottom, 1 times 1 is 1. Upstairs, we get 2 times 3, which is 6. So I have 2 to the 6th power. Now, what I remember about 2 to the 6th power is, let's go back to our friendly numbers here. 2 to the 6th is 64. So I always remember that one because 6 and 64. And then that way I know 2 to the 5th, that's 32, or 2 to the 7th is 128. Okay, let's try some other examples. Now what we have here, so I had a teacher explain these to me and say that this is like the number 4 nightclub. Anybody can go in, but only groups of 4 can leave. So the first thing we want to do is break down that 81 to give us nice friendly numbers. If you do that, you get 4, 3 to the 4th, x8, y4, z12. Now, just a little bit of a reminder here. Remember, if we have something like x to the 2/3 power, that's the same as the cube root of x squared. So we take this number that's on the bottom and we boot it to the front, or alternatively, we take the number that's in the front here and we boot it to the back. So that's what we're going to be doing here. We have 3, 4 over 4, x 8 over 4, y 4 over 4, and z 12 over 4. Now let's simplify those guys. 4 over 4 is 1, 8 over 4 is 2, 4 over 4 is 1, 12 over 4 is 3. So when we simplify this down, we get 3 to the 1 power, x squared, y to the 1 power, and z to the 3rd power for our final answer. Oops, I forgot to write that this is 64 up here. So 2 to the 6th is 64. I'm like, oh, it's easy to remember, and then I forgot to write it down. So 64. Now, so for that one, 3, x squared, y, z to the 3rd. All right. Looking at number 4, same idea here. So let's go ahead and remember that we need them in groups of 3 for this one. And I already see that we have a group of 7 and a group of 11, which is not a group of 3. That's okay, we can fix that. First, let's break down that 54. Doesn't sound familiar to me, so let's go ahead and do some prime factorization. Now I know 54 is divisible by 2, and if I do that, I get 25 plus 2 is 27. This is gonna be 3 and 9. Now 2 and 3 are both prime, and then 9 is 3 and 3. So what we have here is the cube root of 2 times 3 to the 3rd power. Now, as I said, we want to make sure that these are in groups of 3. So instead of saying m to the 7th, what I'm going to do is say m to the 6th times m to the 1. Because remember, in our rules of exponents like this, that equals m to the 7th. Then I do n to the 9th times n squared, because that will give me n to the 11th. So let's take a look at these. Which ones of these do we have that we can take out? Well, this is a group of 3, this is a group of 3, and this is a group of 3. So what we do is we move these guys to the front. So now I have 3, 3 over 3, because I'm taking it out. I'm booting that 3 to the back. So m 6 over 3, n 9 over 3, and then I have the cube root of all the stuff remaining. So that's 2m n squared. Okay, so let's make this look a little bit nicer. This is going to be a 1, this is going to be a 2, and this is going to be a 3. So 3m squared n to the third, and then we have the cube root of 2mn squared. All right, let's try another one. So this one looks a little bit different, but we want to make sure that we're using those same rules of exponents. So remember, we can take this 3 and boot it to the back. So what we really have is negative 64, 4 over 3. So let's think about that. We know that negative 64, that's 2 to the 6th power, right? But what I actually want to do first is when you have a fraction in your exponent, a rational number, if it's an improper fraction, we can actually take something out here. So negative 64, 3 over 3, times negative 64, 1/3. So negative 64, 3 over 3, is just negative 64 to the 1 power. Times, now let's do the little side work here. Negative 64, remember, that's 2 to the 6th. So negative 2 to the 6th power, that's the same as this negative 64 here, times 1/3. Now remember, I can multiply these together. So if I do 6 times 1 over 3, I end up with 6 over 3, which equals 2. So this guy all right here is negative 2 to the 2nd power. Negative 2 to the 2nd power, that's positive 4. So we have negative 64 times positive, times positive 4. So negative 64 times 4 ends up with negative 256 is our final answer for this guy. Okay, so let's take a look at another one here. Example number 6. So we have 9 to the 1 power over 9 negative 4 to the 5th. Negative 4/5 power. So remember, when we're looking like this, it's subtraction. So what we have here, there's a 1 right here, because if it's not shown, it's an exponent of a 1. So what I have here is 9, 1 minus negative 4 over 5. Let's just worry about that fraction bit for a second, and then we'll slap it on a 9 when we're done. Remember, add the opposite when you have a subtraction. So really we're saying 1 plus 4 over 5, which equals 1 4/5. But you want to make sure to turn this into an improper fraction. I think what we can do this a couple ways. So this is 9 over 5. Remember, 5 times 1 is 5, plus 4 is 9. So what we have here is 9, and then our exponent is 9 over 5. But remember, I said if you have an improper fraction, you need to split it up. So this is going to be 9 5 over 5 times 9 4 over 5. See, we have 1 whole and 4/5. 1 whole and 4/5. I was going to show it both ways so that you could see. So this guy right here is just to the 1 power. So we have 9 to the 1 power, and then this one we can't do anything with because we could do like 3 squared, but let's see. Let's try it. So 3 squared, 4 over 5. So actually that will work, because what we get is, remember, we multiply these, so we get 3 8 over 5. So we're going to do the same thing that we did over here. We're going to say, okay, 3 5 over 5 times 3 3 over 5. Okay, that's 1. So we have times 3 times 3 3 over 5. So what we have here is 9 times 3, which gives us 27. And then we've got this lone star here that we can't do anything with. So this is the 5th root of 3 to the 3rd power, which we know is 27. So your final answer would be 27, and then the 5th times the 5th root of 27. Okay, let's take a look at another example. Y to the 4th to the 1/6 power. Again, just remember, you have to multiply these. So we end up with y 4 over 6, because if I multiply 4 over 1 times 1 over 6, we end up with 4 over 6, but of course we reduce our fractions. Divide by 2 on the top and the bottom, we end up with 4, I'm sorry, not 4, y to the 2/3 power. So you can either leave it like that, depending on what the instructions say, or we can turn that back into the radical form, which looks like this. Either answer is acceptable, depending on what your instructions say. Make sure to follow that. All right, let's look at this guy. Now this one's tricky because we have a 4th root and we have a 7th root. I think what the easiest thing is going to be is turn these guys into 6 over 4 over x 5 over 7. So up here, what we can do is say, cut those in half, and we make that 3 halves. Now remember, this is just a subtraction problem. So what we have is x 3 halves minus 5 over 7. So we have to have a common denominator here. So multiply this by 2, 2 times 7 times 7. So now what we have is x 21 over 14 minus 10 over 14, which gives us 11 over 14. So my final answer here would be x 11 over 14 if I wanted it in exponential form, or if I wanted it in radical form, it would be the 14th root of x to the 11th power. Hopefully you found this helpful. We'll see you next time.